Okay, here's a video on ALEKS examples involving the normal distribution and normal probabilities, how to calculate those and do these problems of this type. I do have another video that talks a little bit more in depth of what the normal distribution is and what it represents and how we use it in terms of the generic sense and how it kind of fits in the big picture. But for right now, this video is just going to focus on specific exact ALEKS problems. If you want more information on that, just look at that other video. It's not too long, but it does give, the background in it and so forth. So let's jump into this problem here. We are asked to find shade a region and give a standard normal probability. And we're asked to do the following here, where we are given a standard normal graph below. Now, when you see this phrase standard normal graph, what that implies or what that means is we're dealing with the normal curve or the normal density with a mean of 0 and a standard deviation of 1. So the standard normal always means mean is 0, standard deviation is 1. And we're asked to do two things. Number one, shade that region down below to the left of 0.5. All right, so we'll show you how to do that over here. And then we are going to find the area underneath that curve, which does represent a probability or a proportion, depending on how a question is worded. But here we're just asked to just find the area. Okay, so area can represent, a couple different things. So what we want to do first is go ahead and shade that region. So what we do is draw a vertical segment. We're going to come over here to 0.5. We'll just click there, and then we'll click the shade button and shade to the left, and there you have it. So part A would be done. We can use the table, okay, which, again, is not really I guess it's old school, and you can go through and do that, but it will give you that. If I look up 0.5 here, let me see if I can find it here real quick. Okay, there it is, 0.6915. So we could do that if you want. 0.6915. Or we can use some of the software available here, like the ALEKS calculator. So notice this has a probability of Z. Okay, so again, this could be looked at as a probability problem also, being less than 0.5. Okay, and we hit equals here. And there is your 0.6915. Obviously, we would have to round that there. And then we can also use this go back, and if you saw the other video on the binomial, we were dealing with that. We can use the normal calculator, and again, where that is found is if you just go to your class resources. There is a link right here to download that Excel file. Okay, so this is the Excel file here. So what we need to do is, this can be used for any normal curve. And so we're going to use the one, obviously we said the standard, so the mean is going to be 0 and the standard deviation is 1, and the value we're interested in is 0.5. So we'll go ahead and type those in, and try not to type over the numbers. If you see I highlight here, there's a formula. So if you type over top of that, you're going to, I guess, mess up your spreadsheet. It's set up that you only type in or overtype on the red values. Okay, so those you can change. I don't know why this one down here is not red. Again, this is not mine, so I'm kind of, well, we'll cross that bridge when we get to it. Okay, so but anyway, this is what we're looking at here, and we give the left probability. Also actually gives the area to the right. If you added those two, they would add up to 1. But here is our 0.6915 here. Okay, and then the other option, you can use the go back to the Statlet main menu here and get into normal distribution. So we'll just jump in there with a mean of 0 and a standard deviation of 1. Plot that distribution. We want to go to the left of a value, so we'll just do that and put in 0.5. So this one here is a little bit more I don't know, conducive in terms of, just manipulating a little bit and seeing the picture all at the same time. But here again, obviously, once we convert to a decimal, we would get 0.6915. Okay, so a couple different options there. I don't know if I'm going to go through all of them and all these examples, but there you have that. All right, so we did the standard normal values here. I think that's what we did, right? Shading area. Okay, that's the one we did right there. Okay, so we want some standard normal probabilities. Those will be done just the same way. So let's go ahead and find the probability here, and then we'll get into some of these standard normal values and so forth. Okay, so let's just I'll tell you what, let me go to this one here first, standard normal probabilities, just to show you. I think, if I'm not mistaken, this one here. Yeah, okay, so they just give you those right here. I'm not going to go through this example, but that again would be either looking them up on the table. In the table, you got to get creative, just like the calculator when you do greater thans. Gets a little bit confusing. And that's what's nice about the table values here. I'll tell you what, let me just expose these, because that way I am going to go through this a little bit quicker here, and I won't spend as much time. One of the things you might have questions about is what's the difference between greater than or equal to, or less than or equal to, or less than. And there is no difference between less than or equal to. This is irrelevant, because if you look at it, if we include that value and consider area, the area of a segment is 0. I guess maybe would be the best way of making sense of that. But to get the 0.896, I could go back to my sheet here and just type in the value that we got the mean and standard deviation. So I'm going to type in 1.26. All right, so I'll go ahead and type that in. And there's your 0.896 right there, and the right probability. So it doesn't matter if I go less than that. If I put in the negative 0.78. Notice again, it's just giving me the 0.782. Okay, and this one here we'd have to get a little bit creative with to find the in between those values. We'd actually have to find one of them, right? 1.199, and then subtract the area to the left of this one. That's actually when this technique could come in be much more useful to you, to use to use this. So if I just slide this over a little bit, just so we can see them both at the same time. And if I go between two values, okay, and go negative 0.88, and go to the right boundary here, which would be 1.99. Okay, calculate that area, and there again we have it as the 0.787. Okay, rounded to 3 decimal places. So sometimes you may want to kind of go back and forth between these different. Let's see if I can drag my thing over here if I can. All right, there we go. You may want to go back and forth between these different tools that you have to essentially work with here. So that's going to be kind of up to you how you want to handle that. All right. Sorry, I'm jumping all over the place here. Okay. So so we did the standard normal values. I guess that was, what was it? Yeah, that one. Okay. So if we go ahead and look at the advanced problem here. Told you I wasn't going to do all these, but here they're actually asking you to now go ahead and find a value C to get a specified probability. Now this gets a little tricky here, because it's going to actually involve some algebra. All right. Now keep in mind the concept here, and that is, and I'll maybe show you on ALEKS once we're done here, and I'm going to try to speed up things here instead of writing all this out. I do have an iPad here, but I think we're just gonna look at their solution, and I'll explain it to you. Where does that number come from? In other words, we need to know where we want to start shading on the left and stop at 1.11 in order to get a specified area of 0.8486. Okay, so this one here, it's not very, what I would say, practical in the sense of has many real life applications. But for this here, you're going to have to do these types of problems. So we'll go ahead and get into this. All right, so what we want to do, just like I said here, we want to find this value C, where to start and stop at and have that area there, okay? So the idea here then would be to go ahead and do the following, okay? We would want to go ahead, first of all, and figure out, this area right here, okay, this large area would be this area minus this area. So in other words, we're going to focus on this little piece right here. Okay, and by doing that, what we would do is find, this is going to give us the area to the left of that. So they're using these tables and restricted calculators, but ultimately they're finding this area right here. Okay, and so when we do that, that's equal to 0.133. And so now what we'll do here is to find that area over here. Okay, set up this equation, which is the probability Z is greater than C. So that would be this one here. And that one is going to be equal to this plus this. And you can just see that, right? Since we would just add these two regions together, that would make up this big shaded region, okay? Now, if you have to stop this and pause, that's fine, just so you can kind of get it straight in your mind. So it's kind of like this. If we know this value right here, they give us that, right? That was given in the problem. And we found this one over here, okay? And we do that just by, again, finding the area to the left of that, subtracting it from 1 and getting that. We could do this actually on Staplet and just get it directly. We get this sum total here, which is 98, okay? So that idea here now is that, when we come over here to 0.98, we found the area to the right of that curve to be 0.9821, okay? So that's this big area right here, okay? So that is going to give us that C that we're looking for. And we could look this up on the table here, this command where we find a Z statistic, right? That has a specified area to the right. And that's how, some of these tables work, okay? They show you that example here. I would suggest you instead use your ALEKS calculator. So this would be just typing in the Z of 0.9821, okay, like so, and I hit enter, and there's the negative 2.10 if I round it to 2 decimal places, okay? So that's how that comes up. So this one here is kind of a little bit of a, I guess maybe I said algebra, but maybe more of a kind of piecing together some concepts here to really try to figure out, what is it that we're trying to do here? We're trying to find a value here, right? Actually, this C, and they gave us this value right here, this 0.864. And if we just find the rest of that area over here and add those two areas up, which is what we did here, okay? So if we just find this missing piece to the right of that, and then what we do is we just get it directly off the calculator here and find the area to the right of that, okay? Or the Z statistic that gives us that area, which is a 0.9821, okay? So this much of it they gave us, we figured the rest of that out because we did know that Z value of 0.1 or 1.11. And then we go ahead and, like I said, just use the direct calculator command here, which is this. And there you have it, okay? So that is a standard normal advanced, okay? Finding normal probabilities basic, okay? So I am going to jump into one of these, okay? So now this one here, they start giving you some other information here. Suppose the antenna lengths of this wood lice are approximately normally distributed. I don't really know what those are, but anyway, we'll just we'll assume it has something to do with antennas. Okay, but I guess that makes sense. That I'm sure that's a bug, and bugs have antenna. Okay. So anyway, we have a normally distributed with a mean of 0.2 and a standard deviation of 0.05. So it says what proportion of these wood lice have antenna lengths that are at most 0.18. Now, we could go ahead and use this calculator here. We can go ahead and use the spreadsheet. I'm going to start off actually with the technique where we're going to use, let me see if I keep jumping into that one there, and that's not what I want also. Let me just kind of move. I'm jumping in on all sorts of things. What I'm looking for is this one right here. Okay, so let me go back and type this information in here. I'll tell you what, this would help if I just drag this over here. So that way I could slide this back over. Okay, so so anyway, we could enter in the mean of 0.2 and the standard deviation of 0.05. And just highlight that 0.05. Okay. And what that's going to do, I'm just going to replot that. That'll should clear all this stuff out. Just get that out there. Okay. So that's what the distribution looks like. It's centered right here. And now it says what proportion are at most. So at most would mean that's the highest would be 1.8. So we want to know at most 1.8 and less than that. Okay, so now we're going to go less than that value to the left of that value, which would be 0.18. Okay. So I go ahead and calculate that area, and it's 0.3446. And 4 decimal places here. Let's go ahead and slide this just a little bit, not that, not this, a little bit more over. I'll tell you what, I'm just all over the map here. Sorry about that. I should probably close some of those windows. But anyway, let me type that in, 0.344 Okay. So let's go ahead and check that. And sure enough, there we go. We got that correct. And probably the easiest way of doing that. However, if we wanted to, we could again put in that value here, those values of 0.2. So let me go ahead for the mean. The standard deviation of 0.05. And the data value we're interested in, which is 0.18. And so if I put all that stuff in, here's our 0.3446, okay, because that's the left probability. Now, the reason I showed you this one first was the fact that you actually got to see it, okay, at most 0.18. Here, you don't have really any visual to see, but you do, of course, have the numbers calculated. So, you know, that one could be, you know, up to you. You know, it depends on how you want to handle that. Again, to find the area here, the problem with finding the area to the left is this only gives you the area to the right, okay? So what we would have to do is type 1 minus. And also, we not only that, we would have to find the value for z that goes along with that. So if I substitute it into that formula where z is equal to the x, I don't know if we have the formula sheet here or not. I don't think we do. No. Okay. So we would have to get the formula sheet where x is equal to x minus mean divided by the standard deviation. So we would actually have to type in first to get the z value of the x, which is 0.18, subtract 0.2, divide by 0.015. That would turn out to be negative 0.4. Okay. If you don't believe me, just you'd have to. I don't know, I guess let's just go ahead and do it. So, all right, so if I take the x, which would again be 0.18, I go ahead and I subtract the value here, and I should probably use parentheses. So let me go back. So what is that? You said it was 0.18. And I'm going to subtract the mean, which is 0.05. No, it's not. The mean is 0.2. And now I close that up and then divide by the standard deviation, which is 0.05. Okay, so there's my negative 0.4. And then once I knew the z, then I would have to find the area. This only gives me the area to the Oh, this does give you the area to the left. I thought it gave me the area to the right. Can't keep track of all these. Okay. So then all I would have to do is just, can type that in. Now, if it asks the area to the right, I would have to actually, again, subtract that value from that X, find that probability and then subtract it from one. Okay. So, again, a little bit more cumbersome to work with there with the ALEKS calculator. This kind of does some stuff for you. And like I said, this actually gives you a pretty good picture of what's going on. So let me try to situate these things again. So, okay. All right. So that's one of those. So that was the standard or the normal distribution, finding a probability advanced. The other ones here, let's see, shading, we did that. Okay, so yeah, that's the one I did, the standard normal, finding the mean and standard deviation. This is another, I'll tell you what, I'll do this one. We'll look again. There's a lot of writing on this one. It's a little bit more, what do you want to say? Just a little bit more involved, okay? And so let's take a look at this. We have germination for cauliflower seeds, normally distributed. They give you the mean. They also tell you that 80% of those germinate in 6.2 days or more. So we want to find the standard deviation of the time scale. So the important thing here to note is that they do give you some values here, okay, that we're going to need that are critical to be used here. And we're actually going to go back and this time we are going to solve an algebraic problem, okay? So let me just jump into this. They have everything over here, and I think this is the quickest, best way of doing this. But so given from the information, they say that probability, right, is going to be greater than, right, X would be the number of times taken for the germination, okay, where the mean is 7. Oh, these are days. Okay, so X is greater than or equal to 6.2 days. All right. And what we're going to do is that is the same thing as the probability of X being greater than that 6.2. All right. So what we end up with is this idea that this is the equation for Z, right? So we want to first of all, find a value for Z that we can substitute in here. And once we know what this number is right here, then what we're going to do is we're going to just be able to solve a simple inequality involving algebra. All right. So, so how do we do that? Okay. Well, the first thing we have to do is find use that other number, right? Greater than 0.62 is going to be 0.8. So since it's greater than, we have 0.8 on the right. And we don't really know what this Z is right here, okay? So what we're going to do is we want to find the value Z that has an area of 0.8 to the right of it, okay? So if you remember, we did that in that other problem here with that calculator command, all right? And then what we're going to do is say, well, that Z, this is what Z is, right? Because the formula is Z equals X, which is 6.2 minus the mean, which is 7.1, all divided by the standard deviation. All right. So if you can imagine a Z equals there. And I'm just trying to do this in a way that, it's not going to be too much writing here. And so you can understand their reasoning here. Okay. So again, this is Z being, all I did was take this thing here, I standardize it by taking the X minus the mean divided by the standard deviation, X minus the mean divided by the standard deviation, okay? And this, again, turns out to be Z. So I want the Z with a 0.0 or 0.8 or the 0.8 area to the right of it. I find that value out here, and that value on the calculator is negative 0.8416. So just to show you that real quick, I will use that command for 0.8 and I hit enter and there it is. Okay, so that's how we get that. Now, once we get that, you can see that we have a very, very simple equation to solve here, okay, which we kind of got from the inequality here. And that is, this is the z, right? Z is equal to x minus mu over sigma. Okay, so if they would have given us z in the beginning, we would have been able to, just substitute directly into that formula. However, since they gave us the area, we had to go back and find the z first. All right, so that was essentially, what we were doing here. Okay, so they gave us that area. So given that area, now we can solve this. So I don't know if you want to get into all of this stuff, but that's what that meant. I explained it to you, but really what you have to do is just find the z statistic that they imply in this problem here, and then set it equal to the formula for z, which again is x minus mu over sigma. And of course, they gave you x and they gave you mu in the original problem up here. Okay, this was x and this was mu. Okay. All right. Now we're again wanting to find the standard deviation. So we're dealing with four variables right here. Okay. X, Z, X, mu, and sigma. So they didn't give us Z directly, but they gave us information that we can find it just like this. Okay. So we plug that value in. Again, all we have to do is some simple algebra. We multiply both sides by sigma, divide by -0.8, or just subtract here and divide it by that number. I think you can do the algebra in your head there and you get the 1.07. Okay, so we go back to the equation here, and I'll just, so you don't have to watch me type that in. There it is. Okay, so that is the explanation. And like I said, without me doing a bunch of writing on my iPad there, I think that's probably a little easier to do that way. Just kind of look at their explanation, and hopefully my description made it easier to understand and not harder to understand. So, all right, so that's going to wrap up our normal calculations and probabilities here. It looks to me like all we have to deal with here is this idea of sampling distributions and the central limit theorem. So we'll be back to take a look at some of those. Once again, I did a video on that, and I'll say that at the beginning of the next video as well. So, all right, hope this helps as always, and we'll see you next video.